Good morning, good evening, good afternoon, everyone. It depends on where you are. I'm actually really excited today to work with Stefan, my colleague, to have some sort of like hands-on workshop for Milvus 2.5. We launched 2.5 actually just like a couple of days ago. We already had like lots of feedback from the community. People seems very excited about the new, especially the new full text search feature. And a lot of people ask us, oh, how exactly we're using it? We could use it, leverage it to build our own little app. We already have a bunch of resources on our website, milvus.io, and also zillow.com. So if you want to check, I'm going to put the links in the below in a little bit. So without further ado, I just want to introduce Stefan Patipo, one of our DevRel here at Zillow, to talk about Milvus 2.5. I'll just hand it over to him to share his screen. Give me a moment.
Thank you. Thank you. Woo, woo. And you should see my screen now.
Yes.
Perfect. Thank you very much for the intro. Thank you everyone for joining as well. So yes, today I'm here to talk to you about Milvus 2.5, which has lots of different releases. I'm going to go through most of them to actually explain what's happening, what we released. And at the end, I also have a live demo of the most exciting thing, which is full text search that has been released. So yes, let's go. As introduced, I'm Stefan. I'm a developer advocate at Zilliz and Milvus. You can find me on basically all the socials. If you have any questions related to GenAI, vector database, LLM, anything, feel free to hit me up. And for the people that are not familiar, I'm assuming most of you are familiar with Milvus, but for the people that are not familiar, Milvus is what we call easy to start. So you can start with a pip install on your laptop, and then you can plug it into different AI tools. But we're also ready to scale. So you write your code once, and you run it everywhere at scale. So we have three different offerings. We have Milvus Lite, which is mostly like for prototyping and small scale experiments. This is the one you install when you run pip install, and it scales to about 1 million vectors. Then you have Milvus Standalone, which comes from like a Docker image. This one supports up to about 100 million vectors. And then you have Milvus Distributed if you want to run things at really big scale. This one runs on Kubernetes, and then it scales to about 100 billion vectors. But I'm not here to talk about that today. I'm here to talk to you about 2.5. And what's new exactly in 2.5? So we're releasing a new bitmap index. We also releasing Nullable and default values in Scala fields. We also have a new cluster management UI that is in beta and full text search. We also have a couple of other things, but I invite you to check out directly the release notes on milvus.io, and then you can find like everything there. But what is exactly the bitmap index? Sorry, for the people that are not familiar, it's an indexing technique that is designed to improve your query performance on low cardinality Scala fields. So, for example, imagine you have something that is containing gender information with only 2 values, male and female. That's where bitmap is really going to shine. And it consists of 2 main components, so bitmaps and keys. And as a general guideline, what we recommend is that bitmap indexes are really effective when the cardinality of a field is less than 500. So it's really like not an index you're going to build by default, but it's really in some specific use cases. And to illustrate a bit my points, you can see what a bitmap index is here directly. So on the left side, you have to imagine you have your documents, with like different IDs, and then you have different categories, and then you have a boolean, which is saying if it's public or not. You can then create a bitmap index for the category. So then it's going to be like binary. Is it part of tech, or is it part of news, or is it part of finance? We can see this first one for documents, it's the category is tech. So we have a 1 here and 0 everywhere else. For the second one, category is news. So we have 1 in the news and 0 everywhere else. And then we have something similar as well for the other column, which is public. So this one is either true or false. And again, the first document is also public. So then we can say that public is true is equal to 1, sorry, and false is equal to 0. And then we do that for all the other values. And then you have to imagine that if you're going to search for a document that is tech and public, what we're going to do behind the scene is that we're going to do a logical AND. So we're going to, look at the different columns, and then we do the logical AND, and then in the end, we only return the one that is actually matching. So if you want something that is in the tech and public, it's only going to be the ID number one. So then that's what we do here. We have one here, and one here. Logical AND results in one here, and then everything else will be at 0. So that's then what we would return. And that's new in 2.5. If you want to create, if you don't know other codes, here's a sample. So, you're just going to create, you're invoking your Milvus client, sorry. And then you're going to add an index to index parameters. And you're just going to say, okay, this is the scalar field that I want to index. In our case, it's category. I actually want to build something that's bitmap index. And then you're just going to give a name to the index that you want to create. Then you create this index, and then we'll do everything for you after that. So that's how it works. And yeah, this has been released. Another one is nullable and default values in color fields. So we now allow you to set nullable attribute and default values, except for the primary fields. And the good part is that for fields that are marked as nullable, then you can just skip them when you insert data. And that is very useful if you want to migrate from another database, for example, because then you don't have, to populate all the fields. You can just, populate the one you're interested in, and the rest, you can just keep them. For the code, if you have a look, basically, again, you start your Milvus client, and then you create the schema. Let's say you're going to have different fields. In this one, you have the primary field, which is going to be ID. Then you're going to have the vector field, which is just the vector. And then you're going to say, okay, I'm creating a field that is called age. And this one can be nullable. So you define it here, you put nullable equals true. Then, you're going to create your index, and then you're happy. Then you create your collection. And then when you're going to do the insertion, what's going to happen is that here you have your list of data that you want to do the insertion of. And you're going to give an ID, then you give your vector. Then for the first one, you actually give a value to the age. For the second one, you can just put none, which means then we don't care. And you can also just not put it at all if you're not interested. And then you can insert your data, and then Milvus will not throw an error. So this is like really useful and can be very, very useful, in particular if you migrate from another database. Then we're also releasing cluster management UI, which I'll show you a bit later on. But basically now, once you start this Docker image, you don't have to install anything else. It's already available. It's already packaged in there. And it's very useful, actually. It allows you to visualize a lot of Milvus information, about the database, about the collections, about queries that can be slow or things like that. You have actually a lot of information in there. We also migrated our HNSW from HNSW lib to face. And we're also releasing cluster compaction in beta, which allows you to accelerate searches and reduce costs in very large collections. But there's even more, because our vision is just more than just vectors. So we believe that the future of search is combining different search paradigms. So you have semantic search, keyword search, and then filtering. And what we want to have is we want to have everything in one platform. Before, our release, what you would do is that, you would have like a big platform, which like you have vector search, which is great for semantic understanding, but then it might miss exact keyword matches. So then to solve that, what you would do, or what some people are doing, is that you run two separate systems. You run your vector database for semantic search, and then you run Elasticsearch or something similar for keyword search, which is not bad per se, but then you just have like a complex architecture because then you have to now maintain two different systems. So this is our solution. Full text search in Milvus 2.5. And I'm just going to take a step back here before I introduce everything, because I'm not sure if everyone is familiar with how it works. So I'm just going to introduce a bit of the concept, and then I'll explain exactly how it works in Milvus. And then after that, we'll go into a live demo. So first, we'll go we really take a step back and go back in time, basically. But let me introduce you to TF-IDF, which is a full text search algorithm that is based on terms and document weight. And basically, you have TF, which means term frequency, which measures the weight of a document. The more terms it includes, the more important it is. And then you have IDF, which is inverse document frequency, which measures the weight of terms. So the less common it is in a document base, the more important it is. But then that was cool, but then you have some problems with it. So then BM25 came, which is an improvement over the TF-IDF algorithm because it helps you like from preventing words that occur too frequently from dominating the score. And also it reduces the TF-IDF bias towards long documents because TF-IDF, if you have very long documents, then the words are going to have more weight, which is not what you want. And what's so good about it is that the implementation is simple. You also have good retrieval performance, so you have good queries per second, and the accuracy is also high. And it's also what's used by others in the industry. So Elasticsearch is using it, Apache Lucene is using it, MongoDB Atlas Search is also using it. And why do we care about BM25? The reason is that we really want to, augment the search quality of embedding-based semantic search. And we also want to be able to provide search with more emphasis on keyword matching. And what we want as well is to have easy hybrid search of BM25 plus dense embeddings in a single system. So you don't have, to maintain two systems again, and then to have them talk to each other. And just as a bit of an intro, so this one for BM25 and everything, we're not using dense vectors, we're using sparse vectors. So just as a reminder, or for people that might not know, so sparse vectors are really high dimensional vectors with only a few being non-zero. And they're usually represented as a dictionary where you have the position and then the value. So if you look at the image here, on the first part, we have the dense vectors, which is dimension 5. And then, you then have this list that is going to be a length 5, and then you have the values. For sparse vectors, it's a bit different. Let's say you have 10,000, a sparse vector of dimension 10,000, then only a couple of them might have a value, and the rest will be 0. And so what you care about is that you only care about the values that are non-zero. So then you represent everything in a list where you have, the position of your vector and then the value of it. So you can see here, position number 2 is 0.2. So that's what you have saved then here in this dictionary. And then the same for the other values. And that's basically sparse vectors. And the problem with them is that because they are extremely high dimension, L2 or cosine will just not work due to the curse of dimensionality, because all the mass spreads, on the surface of like very high dimension. So they basically all have the same distance to each other, which means, like if you try to do like approximate nearest neighbor, then it will just be meaningless. So how do we compute BM25 using sparse vectors then? Well, you had what we call the old approach, which is, you would get like some statistics of word distribution and document length. And then you would encode your document and you insert it into a database. And then when you do the search, you encode the query and then you rank it by IP score. But the problem with that is that, the statistics are like static. It's once they're trained, they can't be updated, as like documents are being added or removed. And also the user has to manage it themselves, which can be a pain, like sometimes you just want to add document, you don't really want to think about that. So if you see it, this is basically what you have. So you have your document or your query, and then you're going to have your text analyzer, you're going to have your statistics management, you have your vector database, and then you build or search on the sparse vector index, which means like here is a very simple example. Let's say your document is just hello Milvus. Then you're going to put it through this text analyzer, which likely has like tokenization and filtering and everything. We're going to see that a bit more in details later. So then this sentence, this hello Milvus, is then separated into 2 words. You also you don't have any capital letters anymore. And then you're going to create, this like BM25 on it. And it's like not bad to say, but the problem you have here is that most of it actually is done on the client side. So, like the documents and querying is done on the client side. Tokenization is also done on the client side. And all the statistics, you have to do it yourself. And that's like a problem. That's really annoying. So we took a different approach here because we don't want our customers and clients, to then have to do that. We just want it to be like very smooth for them. So our approach is that you can basically forget about vectors. What's going to happen is that you're going to insert some raw text into Milvus, and then you just search using this text. We'll take care of text analyzing and tokenization, the distribution statistic management as well, so you don't have to do it yourself, the document inquiry vector encoding, and the BM25 base scoring. And this is what it looks like now. So you just have your documents in your query. That's on the client side still. But everything else is done on Milvus side. So the text analyzer is going to be done through Milvus, the stats again, vector database, obviously. And then the build and search on the sparse vector index. So now you just need to interact with your raw data. You don't need to interact with anything else. And for the text analyzer, what's happening is that you just convert raw text into a structured and searchable format. And in Milvus, it consists of exactly one tokenizer and 0 or more filters. As a reminder, tokenizers is just like what breaks, input text into discrete units called tokens. So this is what you have as well when, LLMs are trained on those. Usually you think they're trained on words, but they're actually trained on tokens. And tokens can be words or phrases. It just depends on the type of the tokenizer and the language as well that you're using. And filters, that's what you apply them on tokens to like refine them. And that's like, for example, making them lowercase or removing common words. And what we're using for this one is Tentivai, which is an open source text analyzer. And then that's what we're using. That's what we integrate with. And to illustrate my point, you have your raw text here. You're just going to put that, and then Milvus will take care of the rest. So we have this analyzer. So our raw text is Milvus, a vector database built for scale. And the tokenizer will like separate each word. And then we have the first filter, which is to lowercase everything. So you can see the M for Milvus is now lowercase, same for vectors, same from database and everything. And then the other filter is that you're going to remove the stop words. So stop words are words that are very common in the language. So for English, a and for are very, very common words. So they don't add any valuable information. So then you just remove them. So then you have Milvus vector database build scale. And that's what we're going to score. And we have built-in analyzer, as I've been talking about before. So we have three, we currently support three. So we have the standard one, which is suitable for like general purpose text processing, which applies standard tokenization and lowercase filtering. Then we have one that is English, which is optimized for English language text. And this one is also removing English stop words. So like think of like a, the, for, and those words that don't add any values. We also have the Chinese one, which is specialized for processing Chinese text, including tokenization for the Chinese language, which is very, very different to English. But we also support custom ones. So you could also add your own if you want, if you, I don't know, I'm based in Germany, for example, so maybe you want to build an analyzer on the German text, it might be different. So then it's something that you could do. And for full text search, basically that's what it's going to look like. So Milvus, as I've been talking about before, takes care of the rest. And you just have your text data that you put directly into Milvus. Then we put it through our analyzer. Then we have some different functions that can be called. And then we carry the sparse embeddings, and then everything is stored in the collection. And then we're then going to have this BM25 scoring. So then when you actually query the text, it's again the same. You don't have to think of anything. Milvus will take care of everything, going through the analyzer and everything. And that's now why, that's not what we released, sorry, for 2.5 with full text search. And I have a live demo actually that I can show you. So let me quickly go here. It should be here. Yes. So this is the live demo I have. We're going to go through it. But basically to showcase what I've been talking about before. So usually you would have a vector database for semantic search, Elasticsearch, or different for keyword search, and then you have to have some kind of integration, between both. So now we're going to see how we actually can avoid that. So I don't remember if I actually installed it. Okay, so it's already installed, so that's fine. So I don't need to install it again. But then here, I'm just gonna create my Milvus client. This one is running locally, so I'm just gonna call it. And then I'm also just creating a schema. Like for now, I don't define anything. But then remember here, like before you would have to generate the embeddings, load them into Milvus, pray it works, and then debug when they don't, if you were to use some query text. And then now you can just tell Milvus, here's my text, and then we're just gonna handle the rest. And what would have been talking about when you've seen this image before is that now what's really nice is that you're going to have, a unified system for like both vectors and keyword search. And then it's a built-in sparse BM25 algorithm, so you don't need to like think of anything and need to worry about anything. So we have our basic setup here. So I'm just going to add 3 fields in total. So we have one field, which is the ID field, which is going to be our primary, and then it just auto increments. Then we have another one, which is the text field. And this one we say, okay, we're gonna enable the analyzer here for this field. So then it means that this one will go through our tokenization and maybe filtering as well if we want to. And then we're adding also another field, which is going to be sparse, which is a name. And then this one is actually the data type is be like sparse float vector. So this is what will result. This is what will Milvus will store our result in. So I'm just going to add those fields. And that's what we have. And now how do I define BM25 then, with using Milvus? So we have something new, which is called a function. And then you import the function directly from our SDK. And then you have it here. So we define this function, we give it a name, just, it can be any names, you don't really care. And then we say, okay, the input field, the name that we want is text, is the one that I've created here. So I'm just saying, okay, please use this field. And then the output, gonna use this field that I also created before. So, it's gonna be sparse, which is the one that I've created here. And then for the function type, I'm saying, okay, please use BM25 for Milvus. And then we add this function to our schema. And then that's what's going to do the magic. That's then how Milvus will know, oh, okay, I actually have to use BM25 here. I have to put it through the tokenizer. I have to maybe, use some functions. So then we see it here. Now we're happy. We have, like our function is also defined. And then the input field is the text and the output is sparse. And then this is where I'm going to add my index. So I'm going to say, okay, we're going to add our index on the sparse field, and the metric is going to be BM25. Just to make sure I'm not lying to you, I'm going to drop the collection to make sure there's nothing. And then I'm going to create a collection again with my index parameters. And then I will insert some text that you see here, which is, I'm just inserting some text into the demo collection, which I will create right here. And then we say, okay, the text is going to be, what we have here. So information retrieval is a field of study. And then, everything about different things about information retrieval. So let's do it. So now we've inserted our 3 documents, which are just text. And I never had to think of anything else, like I just literally just wrote some text, said, please insert it to Milvus, and then I don't have to worry about anything else. And now what I can do is that's where the magic is cool. That's like, you're just going to pass your query text directly. You don't need to pre-process anything. You don't need to, update some statistics. You just ask your question and then you get the answer. So I'm just defining some search parameters. And here I'm using the client. So I'm just saying, okay, please search through the collection name demo. And then the query I'm giving is data here. And then I'm just asking, what's the focus of information retrieval? Actually, I've done a typo here. So yeah, you just ask that, and then you say, okay, this is going to be on this sparse field, and I want you to return maximum 3 results. And yeah, basically that's it. Then it would just return me, my ID and the distance. I could actually, like output the text or something, but we don't really care here. You get the idea of like, okay, I just put this data and then I get the result back with the distance. And yeah, basically that's a very simple notebook. But why is it nice? Why is it so cool to have, full text search in 2.5 is that now you have one system instead of two. You don't need to maintain any embedding pipelines, and then you're going to use the same API for both keyword and vector search. And then thanks to that, you have better search quality. So, like you can handle better like technical terms. And then you combine the best of both worlds. You have exact matching when needed and semantic when you need it as well. And yeah, basically that's it. Yeah, that's kind of it. For this, I've seen there's like a lot of questions, so I'm going to take it. And before I finish, actually, I wanted to show you the UI that we have now. So this one has been released, and that's what you have. You can see, system information, and then you can see different statistics about our components. So, the query node, is the query node healthy? Is the data node healthy and everything, and then so you can very quickly see if things are healthy, sorry, on your Milvus clients. Then you can see who's connected. So you can see that I'm actually connected at the moment. So that can also be very useful. And then you can check that also etcd is healthy, and then, everything else is healthy as well. And then you can see the different collections. So I have at the moment, just one collection that I've just created. You can see that it's fully loaded, that I can query it as well. And then, you have some different information about the collection. I won't go into all the details, but you can see the different fields that have been created. And then it's the same, like you can see actually the segments that you have. So in Milvus, we have segments to store data, sorry. And then you can also see the replicas. Imagine you will have like a lot of different replicas. You can have a look at them. So this can be like really, really useful. And then I think, yeah, here. So I didn't have any slow requests, but if you're running Milvus in production, maybe at one point you may have some slow requests. That's where you could also have a look. And then we would show you, like, okay, who's the user, what's the database collection, and for how long has it been running, So this is like, can be like very useful. And yeah, basically that's it for the release. You can also check out our release notes directly on our website, where you can see, everything that I've talked about, but basically in more details. Let me zoom in a bit. Basically in more details, if you want to have, a better understanding of exactly how text match is working, and everything. And yeah, I'll take questions from here. By the way, thank you. Hit up our website. I'm everywhere on socials. Yes, thank you.
Thanks, Stefan. I think we have a bunch of questions here. The first one is how to combine full text search and semantic search in Milvus. Is there a example? I think you just showed an example, right?
I'm assuming, yeah, the question was asked early. So yeah, that's what I've shown. So you just write either you're going to do it either directly on text or then vector, and then we'll figure that out for you.
Okay, so the second question is, instead of using BM25 within the function, could one use a different sparse model for the function like split, v2, split, distill, etc.?
As far as I know, for now, we only support BM25. I might be wrong. It might be something will work in the future, but for now, it's the only one.
I think we support, actually, this question, I don't
We
know
support
the,
split and everything else, but
yeah,
do we
well,
support it in functions?
yeah, I don't know the technical details. I'm part of the marketing team, by the way, I'm sorry about that, but happy to connect. You can actually join us through Discord channel. We can definitely have like a more technical folks to help you in a more detail. But in
Yes.
Milvus 2.4, actually we already support some other type of like a sparse embedding, like a split. What is the other one? And so there's a bunch over there. I can actually try to
Yes.
find the documentation and put it in the chats.
Yes. But I think for the functions, otherwise, yeah, not sure. I know of BM25 for sure. It's
Yeah,
played on
yeah,
the
yeah.
other parts, but yeah.
Oh yeah, yeah. Sorry, I missed that part. Yeah, the function data tune. So our goal is to build this thing we call data in, data out. So you will not have to worry too much about embedding on your end. That product will be a big release happening next year. So stay tuned for that. Okay, so there's some more here. Let's see. I don't know, Stefan, if you know this, how can we migrate vector embedding from Databricks to Milvus? Have you ever met such?
So we
Yeah.
have an open source tool which is called VTS, which helps you migrating different vectors. But I don't know if Databricks is supported or not directly. Let me actually check.
Yeah, I don't think we support Databricks at this moment. Yeah, without like a out of box tool, do you have any idea how to do the migration?
And otherwise, no, it's going to be like you're likely going to have to reset your embeddings and everything because I'm assuming the way we store things are very different. No, I don't see it here. So no, and otherwise, yeah, no, I'm assuming no. Maybe on this cloud, but Milvus from Databricks, no, not
Yeah,
directly.
if you need any sort of like migration support, again, just like reach out to the Discord community. Someone probably know much better can help you answer that. Um,
Yes, I'm gonna share
then
it in the chat.
next question is any variants of BM25 support? My understanding is like I put like some notes here is like support the SWAS implementation of BM25 for now. Uh, if you have any other things specific, you can put it here and we can help you check. So another question is, are we losing anything over having vector search? It worked pretty well for large e-commerce data set.
Just to make sure, losing anything. No, so you don't lose anything over having only vector search, which is I'm assuming what is the question is. Like you would only have better search if you actually use full text search with it on top of it. But you're not losing anything otherwise over having vector search. It works better for like some specific use cases. Let me also go back to my tab, which is here. Um, you're not losing anything by using full text search. You just might get better results in some context, basically.
Okay, next question is it known that these search techniques are more inclined to score documents with shorter length? What methods are available in Milvus to solve this problem?
So what we do is that I mean BM25 is kind of doing that, right? It's normalizing everything over the length of the document, sorry. So I'm assuming that then whatever the length of the document is, we don't really care here. We should still have like a good search, even though the document is short or long, as long as it's not filled with like stop words like the a for, you know.
Next question is, what if we have multiple text fields? Should we add functions for every field for full text search?
So I'm not sure 100%, but I'm assuming yes. Because you might also want to add some different functions depending on the text field. So, you know, like maybe you want one that is like in English, maybe one that is in another language. So then, yes, you would have to do that.
Okay, another question showed in the Q&A is there a launch and implementation for Milvus 2.5 API? Based on my knowledge, we will have it. So that's gonna
Yes,
be something we're gonna work on, but stay tuned. It's probably not available at this moment. We're just like
exactly.
really try to deep down to get the product out first.
Exactly. Yeah, you'll see it coming. We just need to like add it basically to the LangChain ecosystem.
Uh, Another question, how to handle when my document contains tabular data or image? Uh,
Very different thing to what I've shown, but images, it depends. It depends on how you're going to parse them, basically. Either you have some vision language models, which likely will take some screenshots, for example, of your document, and then can like extract the content based on the screenshot. For tabular data, uh, I would say it depends on what it stores. Usually, what I say people is that if you want to store tabular data in a vector database, you may, but it's going to depend on what you have there. If you have a lot of text, For example, that you want to search through vector search, then it's possible, but then the rest you put it like metadata. As you know, like maybe you have the name of the company or I don't know, the country or something, then you can search that through metadata. And for,
Next,
yeah.
okay. So next question is, what document types can be uploaded for vectorization? Do you know this, Stefan?
Do we mean for full text search or in general?
You can
I'm
just
not
answer
sure.
both, I guess.
So full text search, hence the name. In general, okay. In general, anything that you can transform in embeddings. So it can be images, video, audio, text, DNA, proteins, anything you can think of, basically, as long as you have embedding models. Then you can transform them and search them. We have customers using us to search through proteins to actually create them using AI, to create new ones using AI. So that's possible. You can do audio, images, anything you want. You just need to transform them into embeddings.
Cool. Then the next question we see here is from the short document question. Let's say the query is phone and there is a document Samsung phone and all the other codes are like simple description of phones. Could normalization tackle this problem?
In that regards, yeah, then in that regard, it's just, I mean, it's going to look for phone and then it like phone is, I guess, too generic as a term for the query. Like everything, like if you actually have like an e-commerce website where you sell phones, if you search for phone, then there's nothing that is descriptive, you know, so then you would just get anything back which contains phone, which is not very useful, but also the query is not very useful or indicative.
The next question is, what if I have a multiple tag where I want to make search using multiple combination of tags? Any approach apart from storing those tags as separate fields?
Um, Let me think. I have to reread the question. I want to make search using multiple. I know so for vectors, I know we can search through multiple vectors at the same time. So that would be for if I were to if you were to ask this question with like a vector world, then I would tell you you can search through multiple vectors at the same time in the same connection. So then you wouldn't have this problem. For text at the moment, I'm assuming you would have to make multiple search queries.
Okay, next is really more like a product question. What is the best storage option, Mini or S3? Keep latency and cost in mind. Do you have any idea for?
I mean, it depends. Monaio, it's gonna be more, you're gonna like host it yourself, kind of. S3, you just define the endpoint of Milvus being S3, and then we keep everything. Both. I mean, Minayo would then be in your cluster or something, you know, so then technically it's a bit faster. Um, but like the differences are going to be, they're not going to be insane differences. And S3 is also very, very cheap. So just keep that in mind.
Chetan, I think add a
Yeah,
little
that's for
bit more.
text.
Yeah, so if you
Yeah,
want
it's
to
for
add
text. So I
anything for
think for
text.
text would be then multiple query search at the moment, is what I think. But I invite you as well as, you know, Steffi said before, ask directly on Discord so we can make sure, like I'm 90% sure, so make sure, you know, we can ask that on Discord to our contributors that work on that to make sure it's correct.
Next question here is a full text search optional that can use our existing Milvus 2.4.6 embeddings, or was 2.5 is a whole new embeddings?
Um, it's full text search optional. So if you migrate to 2.5, then you wouldn't lose your vectors in from 2.46, like if you follow the migration way. And then you don't have to use full text search if you use 2.5. And that's fine. It's just something that is available to you. You can just continue normal, meaning that you never, you know, ask any query with text. But if you want, you can.
Yeah, I think if you want to leverage this full text search new feature, as Stephen showed, you have to use 2.5.
Yeah, you have to. and then it is the usual migration from like, a version of Milvus to the other. Yeah. And then we'll handle everything for you for the BM25 scoring and everything.
Yeah. Any more questions? Meanwhile, I think that you guys brought up like lots of great questions. So if you have more, we do have something called office hour every week. Let me try to find the link actually. So if you have more questions like technical deployment questions, feel free to go there. We don't have it this week, but because it's like a holiday week, but I think we'll resume very soon after New Year.
Yes, and Chetan, just to follow up, you just ask any updates on bulk insets and series. I personally don't have any updates here, but it would be amazing if you could contact us. Either Steffi or me. You can find or you contact me on LinkedIn, or you could find my email at the beginning, just so we can follow up with you to see that.
Yeah, I think it's a great future feedback. We'll definitely give this back to our engineering team, mentioning someone is looking for this. Stefan, do you have like the office hour link people can find to sign up? If that's a
I
thing,
don't
we
have
can
it on me.
can drop it in the.
I unfortunately don't have it directly.
Okay, we can add this as a part of the follow-up. You guys gonna receive the email from us about the recording. We can just put it over there. Then thanks everyone. Oh, there's one more question. Oh yeah, there's one more question.
Yes, I found the link.
So yeah. So
This is
for hybrid search, if add new data, how does sparse embedding and dense embedding interact? Because when new data is inserted, we need to rebuild the new IDF table and you need to update the new record, which means you need to rebuild dense embedding. Do you understand? I personally, I do not exactly understand the
let me
question.
just share. So I just shared the link of the office hour
Mhm.
in the chat. Let me read. For hybrid search, if I new data, how does possible embeddings and nodes interact? So this one, the way we do it is that, like the IDF table that you would need to usually rebuild it, we will update it for you directly. So you wouldn't need to rebuild the dense embeddings. If I understand the question correctly, how does possible embeddings and dense embeddings interact? Yeah, I think if I understood the question correctly, yes, then you don't need to rebuild everything. You would just like insert, if it's vector search, then you put it through your embedding models and then you have your dense one, and then you would insert the text, and then you say build the BM25 index on top of this text.
Okay, I think this person provided a bit more context. Their
Yeah.
current version need to review the dense when sparse embeddings update.
Yeah. Yeah. Do you want to answer this one?
I don't know the answer.
Ah.
I'm sorry about that. I guess this you put it like anonymous, and we actually don't know how to reach out to you. So if you need any sort of help, I think the real easiest way just like join us on Discord, milvus.io/Discord. There's a bunch of engineers who know the product much better than us, could help you answer the question and help you troubleshoot. Okay, thanks everyone. I wish everyone has a great holiday. So we're gonna reconnect again sometime next year. This will be the last webinar of this year. So really appreciate everyone's support over the year. We'll see you guys soon.
Thank you.
Thank you. Bye bye.